Okay, to finish lesson 5 then. All right, we have a couple more examples to look at before we move in and do a little bit from lesson 6. All right. Composite functions. All right. So in yesterday's work, you were actually doing some composite functions. When it said to do f of g of x, or g of f of x with two functions, you were working on that. And so what we're going to be looking at with example 5 is, okay, here is a composite function. Can you tell me what two functions it took to create that function? And so there's usually at least two different things that you can do to get that. So let's go back and look at one of those first before we go on. And I'm just going to take number 27 here, or no, I'll do number 28 because I think that's one you did. So let's look at 28 here just for a second. And on 28, they wanted us to do f of g of x. So if I do f of g of x, reminder, all that is this here, which means we're going to take g of x and replace this x with it. So we get x cubed plus 1 takes the place of x, and then we also have our minus 1 in there. So this would be 1 minus 1 is 0, cube root of x cubed. Yeah, that one's really nice. It ends up becoming x. But when we were talking about finding the composite functions, okay, this is actually what we were doing. F of g of x or g of f of x. Okay. That was the process for doing it. So they want us to be able to tell them, all right, here's the composite function. What do you do to get there? So we're going to get rid of that. Everybody. Not that far. Okay. So I'm trying to find f of x and g of x, oops, so that when I do f of g of x, I get h of x. Now, there's usually one very easy thing is this. Okay? If you ever have our main parent function, what's the main parent function we're dealing with here? Okay. All right, the square root of x, right, is the parent function because we have the radical. So I can say that f of x is the square root of x. That's the most basic thing is just, okay, my parent function is going to be f of x. So then what will g of x have to be so that when I'm done, I get the square root of 3x squared plus 1? Close. But not exactly. What do I need to replace this with to get this? What do I need to replace the x with to get that? 3x squared plus 1. So that's one option. Okay. The parent function and whatever is inside it or under it or whatever the situation is.
So it's just the same thing?
Okay. Pretty much. Okay. Now, there's another way we can do this too. No. Okay, so that's one way to do it. All right, is I just use the parent function itself, and 3x squared plus 1. But there's another way I can do it. So the other way is look at look at it and see, okay, is there another way I can put something in there for an x and still get the answer? And sometimes there's even more than two ways. But in this case, I think there might just be one other way. So if I look at this, all right, what's another thing that I could possibly put in there? Any ideas that I could use for f of x or g of x? Okay. All right, so hint. Okay. All right. Now, inside this, I have 3x squared, right? I'm going to make this 3x squared. So what can my f of x be then? What would that need to be? The square root of x plus 1. Right? Because I want to replace x with 3x squared. So you always got to think about, okay, all right, so I have this function in there. Can I replace x with that? So remember, the thing is that I'm always going to be substituting that g of x in for my x's. So there's two different ways I could do this. All right? So let's look at this one down here. Square root of x cubed minus 5. So try to find one way where you can get f of x and g of x to get that composite function. And like I said, one way, you always want to utilize the parent function. Mackenzie, you got one? No? Zach? Excuse me, Zach? You got one?
F of x equals the square root of x, and d of x equals x cubed minus 5.
Okay. All right. There's the most basic one. Okay. Use the parent function, square root of x, and what's under it is my g of x. Good. Yep.
Why are we doing a hard way if there's just the
Oops. Because it says to do it two ways. No, that's one way. That's one for f of x, one for g of x. But I'm doing this, so it's got to be, oops. I'm trying to find this. All right, that's one way to get that.
So if I had square root of x minus 5 and then square root of x cubed, is that right?
That's close.
You just want x cubed.
Yeah, that's what I say because
It would just be x cubed, wouldn't it? Boom, Shaniqua. I'm a genius.
Okay.
I did not.
Okay.
wait a second. Okay, this is what I don't understand. Is how come
Okay, number 6. A cylindrical container is being filled with water or filled with water.
Obviously, it's a word.
After T minutes, the height of the water in the container is h of t equals 1/2 t plus 3 inches.
Whoa.
The volume of the water in the container is given by V of h is equal to pi over 4 h cubed. It says express the volume as a function of time by finding V of h of t and compute the volume at t equals 2 minutes. So what we're trying to do, here we have a situation where we're trying to find the volume according to the time, where this gives me volume according to the height, and height is with respect to the time. So I need to put them together so that I can get volume with respect to time. So I'm going to take, since h is equal to this, I'm going to replace h with 1/2 t plus 3. So V of h of t, the volume with respect to time, is equal to pi over 4 times 1/2 t plus 3, that cubed.
You plug the X.
We're replacing this. We don't want volume with respect to height. We want volume with respect to time. So we're replacing
Oh, okay.
this h with the part with t.
Okay, okay.
Now, all right, we have a cube there. Would it be easy to cube that?
Nope.
No.
Not really, okay? So it says compute the volume at t equals 2 minutes. So I want to find V of 2. So I'm just going to replace t with 2.
That's all you have to do.
And find that answer, yep.
Wait, so
And leave pi in your answer. What?
never mind. I was wondering where it's came from, but that's it.
Yep.
So you don't have to do that anymore.
Well, you just have to simplify it.
Oh, I thought we could just leave it like that.
What's 1/2 times 2?
Just like that.
1. 1 plus 3 is?
7.
4, okay. So 4 to the third power is
64.
64.
64, okay.
I knew that. I said it before.
So we get pi over 4 times 64,
That's
and
just gonna be an ugly number, so let's not do that.
what's 64 divided by 4? 16. So this is 16 pi. And our units is in what?
Minutes. Volume.
We're finding volume, right? It may have caught that. Okay? All right. Volume is in, but we're not using inches. It is what kind of inches? Right, cubic inches.
You guys, I was thinking the same thing too, but some of the stuff I said didn't make sense. No. You guys don't, all you have to do is write everything on your note card. That's all you have to do, and you get a decent grade.
I did that. Yeah.
What doesn't work?
Fill your note card up till there's absolutely no space anywhere on the page. That's the only reason I'm just gonna give you advice. You guys are.
All right, here we go. Moving on. Okay, inverse functions. Okay, here's another thing that we did quite a bit of in Algebra C. All right, working with functions and inverses. And so we're going to start working on them today. And we're going to take a little bit different approach to some of it that we do. But the main thing to remember about inverse relations and functions is that we are talking about reflections across the line y equals x, which means that our domain and range switch, that our x's and y's switch. Okay? and all of them. So here we have, this problem talks about, shows me a graph that has a year and population for some city or country. Probably the United States. There's a lot of people there. Okay, it's a world, okay? All right? So, here's the population of the world. But the question might be is, okay, so if the population was this much, what year is that? And we're used to using, okay, I can take my calculator and I can do that. Okay? But when we're dealing with inverse relations, it would be really nice to be able to just stick that population into my equation and find the year that way. Much easier than having to graph it, find the intersection point, or other things.
Can you do that if you would like to do that?
To a certain extent, yes.
Okay, so yes.
To a certain extent, yes. Okay?
To a certain extent.
No.
Yes.
All right, so when we're talking about inverse relations, we can see that all they did here is they took the year and the population and we want to switch them. Okay? So we've taken the input values and switched them with the output values, or the x's with the y's.
But why? What's the point of that when it was perfectly good the way it was?
Can you just turn it?
It isn't perfectly good the way it is, because the question that you're trying to solve needs to be answered with it the other way.
Oh, well, the opposite of what it already was.
Pretty much. Okay? So the result of exchanging input and output values of a function or relation is called inverse relations, or finding the inverse of a function. When we do that, all we are going to do basically is we're switching the values of x and y. It's a reflection over the line y equals x. So here we have a graph. And they want us to graph the inverse and describe the relationship between the function and its inverse. So when we graph the inverse, all we're going to do is switch the values of x and y. So whatever values I have here, I'm just going to switch them. So the point 0.05 is going to become
5-0.
5,0.
So what exactly is the point? I don't understand why we have to make everything opposite.
Because in a lot of situations when you solve things, that it's easier to solve them when you've reversed the input and output values to do it. Okay? Especially in a situation like this where your populations and like that, you got numbers that are very large, it's much easier to work with them if they are the other way when you're trying to find year instead of population. So we look at all of them. All right, here we have the point -1, 0. So the inverse of that is going to be 0, -1. Going around, the point here is -2, -3. So I switch them. It becomes -3, -2. All right. And we just take each point and we change them. So -3, -4 is going to be -4, -3. That's nice. -4, -3, -3, -4. Here I have -5, 0. Which comes 0, -5. And my last one, -6, 5, is 5, -6. And we draw that graph. So when we're dealing with inverses, the reflections over the line y equals x, we're just talking about switching the values of x and y.
Oh, and then you put a little line through the...
And then you don't have to put the line through it, but putting a line through it shows where the inverses go. So if I actually put the line here, then all of my points, oops, that doesn't make two there. That's better. Okay. All of my corresponding points then should be the same distance from that line y equals x, because it's a reflection.
So just making sure it's fine.
So we have the distance from here to here is the same as the distance from there to there. Now, in this case, is the inverse a function?
No.
Is the inverse a function? So the purple one is the inverse. Okay, all right. It fails the vertical line test. Right, we're going there. Okay. All right, graphs of inverse relations. Let f be a function. If a and b is the point on the graph of f, then ba is the point on the graph of the inverse, all right, where we just switched x and y's. The graph of the inverse is a reflection across the line y equals x. So, the definition of inverse makes it very easy to graph an inverse by using parametric graphing mode. Because all we have to do is switch x and y and it'll graph it. So we're going to take a look at graphing in parametric mode then. So first thing you need to do is you're going to need to change your mode of your calculator to parametric. Yep, back to the T's. Oops.
I'll give it a try for.
Oh, it's 90 days. Then I'll just do it again. Of course, I might have to use a different email or something. Right, so when we go to our y equals, we have t's. Okay? So, to graph this function here, the original function, I will say that x sub t is equal to t. All right, we'll always just let x equal the parameter t itself, and then y sub t is going to be the function using t instead of x. And so if finding an inverse is just switching x and y, then all I need to do to graph the inverse of this is switch them. All right. So here's my function. Oops. Graphed. And then to graph the inverse then, I'm going to make x and then my y will just be t.
Are you kidding? Try this another one.
So you typed your inverse first?
Oh, so I just did the opposite one first. Is that okay?
Yep. Oh, wait a minute. See what I get here. Well, that's not all of it, is it? All right. So go to my window, negative, let's go 10 to 10, and by point ones. All right, let's see what we get here then. Okay, that's better. So, what's the inverse going to look like then?
Sideways.
Okay, it's going to go sideways. Now, I'm going to show you something. I know you. How many of you have already typed that all into y2, x2 and y2? All right. Okay. You want to see the way you cheat to do this? Okay, because it was a pain typing that all in, right? At least twice. So you don't have to copy necessarily, but you can go alpha, trace, and there's all of my x's and y's, and we're just switching them, right? So in x2 of t, I want it to be y1t the same, right? Because I want this x to be what that y was, so I just put in number 2. And then it's easier just to put t there. And now I have my inverse is in red. Okay. All right. So much easier to, what?
I was trying to figure this out.
When I typed, I just put y1 here
Oh,
instead of retyping that.
how'd you get
Alpha, trace. All your x's and y's are there, or they're all there.
Well, mine doesn't look like it.
Okay.
Why does it like?
You can actually look at the inverse itself. So let me go back to standard or function mode. Okay. And in my y equals, if I put in 0.9 x to the 5th, what was it? Plus 0.4 x to the 4th. Yep. Minus 0.1 x cubed plus x minus 1. Okay.
it goes backwards? It's 0.1.
And 0.4. All right. Thank you. Plus 1 and minus 4.
Yeah.
Okay. All right. All right. So if I graph this,
0.04.
wasn't it just 0.4?
Yes,
Why did I write 0.04?
I don't know. Okay. So there's the function. And if you remember, there was a way to do it because if you went to second draw, okay, or program, second program, number 8 was you could actually draw the inverse if you wanted to.
What do you mean draw inverse? It does it for you?
Okay, it'll draw the graph, but it doesn't give you any date, any information about it. Is the only reason why.
What?
So-
Down there and you
so-
have that there, they
so-
might as well give you information.
So the reason that we don't use this is because it doesn't give you any more information, but it does show you the graph then.
It's so annoying. Like they
I know, it's just so
they
annoying.
don't like. I don't understand. They have that all ready for you, and they're not
Mine's
gonna help you out. We're rude. They could have so easily just made it so that you know what it is and stuff.
Well, they obviously didn't have the capabilities of doing that. So that's why they show us how to do it with parametric modes. Okay, finding the inverse then. Number 3 says find the inverse of f of x equals 2x plus 1. If it is a function, you must use function notation. Now, you can do this 2 ways. And I showed all my Algebra C students, we just did it, and I showed it to them 2 ways. Here's one way. Switch x and y, then solve for y. Okay? Probably for most of you is what you're going to do. But another way of doing it is think of undoing things, which is actually the same thing. It's just that you're going to kind of think about it verbally in your head while you're doing it. So, what happens to x here? Just look at this function. What's happening to x? If I put a number in for x, what's going to be the first thing that we do? Okay, if I put a number in for x, the first thing we're going to do is what?
Put that in all the x's.
Okay, we're going to multiply it by 2, right? If I put a number in for x, we're going to multiply by 2. So the first thing we do is times by 2. Okay, then what? Okay, then we're going to add 1 to it, right? All right. If I put a number in here for x, I would multiply it by 2 and then add 1. Okay?
Yeah.
So to find the inverse then, we want to undo those things. All right? And when we think about, when we think about undoing things, you have to think of it this way. All right? Every day or most days, when you get up to leave to go to school, you put on shoes and socks, right?
Yep.
Okay? All right. Now, when you go to put on your shoes and socks, what goes on first? Your socks and then your shoes, right? Okay. So if you're going to undo that, you have to do what? Take off your shoes and then your socks, okay? So if we're going to undo what we just did, we have to work backwards in doing that. So the first thing we're going to do is subtract 1 and divide by 2. So I can say then that f inverse of x equals, all right, first thing I'm doing is subtracting 1, and I'm subtracting that from x. Okay. And then we're dividing by 2, and we divide by 2. Are we just dividing x by 2 or the whole thing? Okay, the whole thing. So this equals 1/2 x minus 1/2. And I want it written like that. Do not leave it as x minus 1 over 2. Because you need to know the slope and the y-intercept, and that tells you slope and y-intercept. Okay?
I always get so confused when you can like break it apart and like still use the same denominator and stuff. Why is that?